we have to see some more groups of NVIC priority groups. Okay, the first one is NVIC priority group 0. There are 5 groups. That is the NVIC priority group 0 and 1, 2, 3, 4. So totally 5 groups. We will see one by one. So in this priority group, this is the template or the format. So the first block is indicating preemption priority. The second block of 4 bits is indicating sub priority. Okay, so each block has 4 bits capacity. Totally, we have 8 bits to indicate the priority level. So here you can see bit 0, bit 1, bit 2, bit 3, and here also we have the bit 0, 1, 2, 3. And in this group 0, the preemption priority has no bits. It has 0 bits. So based on the number of bits in this each block, we can consider or we can calculate the number of levels. For example, here we have no bits, right? It means it's 0 bits. So 2 power 0, 2 to the power 0 is equal to 1. So we have 1 preemption priority level. Okay, so we know priority level is always starting from 0, 1, 2, 3 like that. 0 is the highest priority. So this one has only 1 preemption priority level, but here in the sub priority we have 4 bits. Bit 0, okay, whatever, bit 0, bit 1, bit 2, bit 3, it can be any values. So since we have these 4 bits, now we can calculate how many levels we have in the sub priority. So that is 2 to the power 4 is equal to 16. So we have 16 sub priority levels. So it's starting from 0, 0, 0, 0, binary counting. So 1, 1, 1. So if you count everything, so you will have 16 different levels for this sub priority. So different bit combination is indicating different bit level. For example, this is indicating the bit level 0, and the next one will indicate bit the sub priority level 1, and so on. So this is the group 0. So in group 0, as you can see, preemption level has only 1 level and 0 bits, and sub priority has 16 levels and 4 bits. Sub priority have 4 bits and 16 levels. So now next one is group 1. Group 1, what is the preemption? Preemption has 1 bit, only 1 bit, that is the bit 0. So now we can calculate the number of levels. So the number of levels is equal to 2 to the power 1 is equal to 2. So it has 2 preemption priority level. It means it can be either bit 0 or bit 1. So only 2 levels are possible. This 0 is indicating level 0, and then the 1 is indicating level 1. But in the sub priority, here we have 3 bits active. So we have bit 0, bit 1, and bit 2. So 2 to the power 3 is equal to 8. That is the 8 sub priority level we can set up. So for example, the bit combination can be like this: 0, 0, 0, 0, 0, 1, up to 1, 1, 1. So if you calculate, if you count everything, it will be number of levels will be 8. So I told you, right, last week, one trick how to make this 0. This is 1, and this is 10, and this is 11. And then 100, 101, 110, and then 11. Of course, wherever you have empty, you can put the 0 there. So if you count this one, 1, 2, 3, 4, 5, 6, 7, 8. So you will have 8 levels. So each one is indicating one decimal number actually. This is indicating decimal number 0, and this is indicating decimal number 1, and this is indicating decimal number 2, and so on. And this one is indicating decimal number. So you can put the 8421 code to calculate the decimal value. So this is 111. All the 3 bits are 111. So you have to add 4 plus 2 plus 1. So that is 6 plus 1, 7. So because we are starting from 0, so it's ending up with 7. But if you count, it will be, number of levels will be 8. Okay, so this is the sub priority level. So because of 3 bits, we have 8 sub priority levels. And here we have only 1 bit, so we have 2 preemption level. This is for group 1. And next one is group 2. In group 2, each block, preemption block has 2 bits, sub priority has 2 bits. So now how many number of levels? So 2 to the power 2, because 2 bits, 2 to the power 2 is equal to 4. So we have the 4 preemption levels. And same here. So 2 to the power 2, because 2 bits are we are using to represent the sub priority here. So 2 to the power 2 is equal to 4. So we have 4 sub priority levels. Similarly, if you have these 2 bits, it means 4 combinations are possible. 0, 1, 1, 0, 1, 1. So this is indicating decimal number 0. This is the priority level 0, highest priority. And this is decimal number 1, second priority. Decimal number 2, third priority. Decimal number 3. This is the fourth priority. So in each. So if you calculate the decimal number, so you the same technique you can use. 8421 code, you can use the top. So now you can calculate the decimal value. So 1 multiplied by 1 is 1 here, and then the 1 multiplied by 2 is 2 here. Here is 1 1 and 8421, right? So 2 plus 1, that is 3. This 8 and 4 is not needed because we don't have the bits, because bit value is empty. Okay, so this is how you can calculate the sub priority level. And also here preemption priority is also having the same numbers. It's not different like here. This is group 3. So this is group 2. Now we will move to group 3. This is the last group. I think we have one more group. So group 3 is having 3 bits in the preemption block, and we have only 1 bit in sub priority block. So it means 2 to the power 3 is equal to 8. We have 8 levels in preemption priority we can set, and in sub priority 2 to the power 1, so that is equal to 2. So we have 2 sub priority levels, because this is just only 1 bit, either it's going to be 0 or 1. So this is the sub priority level 0 or sub priority level 1. Okay, so this is for group 3. And group 4, this preemption block has 4 bits, all the bits, and sub priority has no bits at all. So that is 0 bits. So now the level calculation is 2 to the power 4 is equal to 16. So we have 16 preemption priority level, and we have 2 to the power 0 is equal to 1 sub priority level. So remember, this group 4 is totally opposite from the group 0. In the group 0, we have all the bits in the sub priority and preemption was empty. But here is the opposite. You see here, group 0, we have this green, all the bits are here in sub priority, and here it was empty. So this is totally opposite in the group 4. So here all the green bits are 0, no bits here, and all the orange bits are here. So that is indicating preemption. So this is how you can remember these priority groups, and each priority group has different bit values in each block, because based on this number of bits, you can calculate the number of levels for first level, this preemption priority, or the second level sub priority. So that is how the microcontroller is taking. So now we can see what we are checking. As usual, we are checking the system clock and then the RCC, and then we are going to the pin, and we are seeing in this pin what we have to do. So this is the port C, pin number 1. So I am setting up here as a extended interrupt number 13, because now this lecture is about the interrupts. And then I have 2 more pins, PA1 and PA2 from port A. So here also I am setting up SW1 and switch 1 and switch 2. These are also extended interrupt or external interrupts. So then you can go to the data sheet. The data sheet of the corresponding microcontroller. Now we are talking about the F103. But if you are going to use L476, then you can open the data sheet of that microcontroller and you will see this how these interrupts are set up. So here, for example, this alternate function input output because the interrupt is coming from externally. Let's see here. So you can see here PA0. So there are different ports. Each port has 0, 0, 0. That is the group 0. And we know how the group 0 we can set up the priority or at least the logic behind the group 0. How many number of preemption priorities and how many number of sub priorities. And you can also go to this vector table in the data sheet. So it will give all the interrupts and its description. So data sheet is really important. That will help you to understand many things. So now, yes, this one is already set up as a external interrupt, number 13. And this is the EXT11. So EXT11 is indicating, you can see this line 2 interrupt. And the priority level is, you can see here, and the sub priority level. So you can see all the details in the data sheet. And of course, you have to check this clock configuration tab. You can set up the high speed clock. That is the maximum value for this microcontroller. That is 72 megahertz. And here also you can come now and then go to the GPIO. So in this GPIO, you set up only one pin, PC13, as the external interrupt here. So all others are, okay, here also we have the PA1 and PA2. Pin 1 in port A, pin 2 in port A. So we are setting up that as an external interrupt. And you can click each pin and then you will have this one in the bottom to change the mode. And also you can set up the clock triggers. You want the rising edge clock or falling edge clock or both. And also you have to enable some things, but because here we are using the external interrupt line 1 and 2 and external interrupt line array 15 down 10. So we are enabling these things. And then you can generate the code. So of course, if you use the F103 microcontroller, you have to use the external LED. It doesn't have the inbuilt LED. So you can set up this some switches. Each switch is giving the interrupt to the CPU. But of course, we can set up the priority level. So based on the priority level, it will consider the switch interrupts and it will turn on the LEDs. These all are about the interrupts and the NVIC, and also you can practice more by yourself to how to use these interrupts.